All right, this is the moment we have all been waiting for, standard deviation calculation by hand. Oh, you are going to love this, and it is going to be just the most amazing computation work you have ever done. So, standard deviation is a little bit of a bear to calculate by hand here, and we are going through this. And the largest data set that I will have you calculate by hand is 4 values. I believe there might be a value of 5 in a certain data set, but we're going to look at examples here of 4 measurements and 3 measurements. Quiz, test, I won't go more than 4, and I don't believe there are more than 4 on a assignment, but to be determined. I don't have those memorized quite yet. So what standard deviation does is it gives us a numerical value that tells us how far apart our numbers are spread out. So if you have numbers that are, spread out, there's a lot of distance in between your numbers, it is going to be a larger standard deviation. If you have numbers in which there is no distance between them, if you have a data set of identical numbers, your standard deviation will be 0 because there is no distance, there is no spread between the numbers. So what the standard deviation number tells you is the average distance each value is from the mean. So we're going to find the mean of the data set and then find how far on average each other individual data set is from the mean. So if there is no variation from the mean, all values are the same. There is no distance, so that would be 0. If your numbers are, deep and wide from the mean, then you're going to have a larger value. So here is my formula I'm going to use. The formula looks a little complicated, but it really is very straightforward, and I think you'll be able to follow it here with our 2 examples. So I am going to identify here, I'm going to work through the formula definition as I do example 1. And what I'm doing right now is identifying in this case, 4 individual values. So observation number 1 I see is the number 6, observation 2 is 2, observation 3 is 3, and observation 4 is 1. So I'm going to label x sub 1, observation 1 through 4 is 6, 2, 3, and 1. So let's find S, the standard deviation of this data set. You might be thinking, whoa, yeah, it's a little crazy. So I am going to take the summation. I'm going to add each individual value from my first to my nth value. So n is the sample size. So in this example here, n, my sample size is 4 because I have 1, 2, 3, 4 values. So what I'm going to do is take each observation minus x bar. X bar is the mean, the average of the data set. So in this example, x bar, the mean, is going to be 6 plus 2, which is 8, 9, 10, 11, 12, divided by 1, 2, 3, 4. So the mean is 12 divided by 4, 3. So I'm going to take each observation minus the mean, take that difference, square it, and then add it to the next observation minus the mean squared, added to the next, and to the next, and to the next, and so on. So observation starting with 1, observation 1 is 6. So I'm going to take 6 minus the mean, which is 3. Again, x bar is 3, squared, summation, add observation 2, which is 2, minus the mean, squared, plus observation 3, which is 3, minus the mean, And then finally, I'll add it to observation 4. Got to get my square in there, minus the mean squared. All right, so I have that all over n minus 1. Again, n is my sample size 4, so 4 minus 1. So I'm going to simplify here. 6 minus 3 is 3. I'll square that. 2 minus 3, negative 1. I'll square that. 3 minus 3 is 0. I'll square that. And then 1 minus 3 is negative 2. Negative 2 squared. And again, this is all over. And I should rewrite my square root here. Everything, both numerator and denominator, are in the radical. So sample size 4 minus 1, we said we'll simplify that to 3. Okay, let's continue here. So we got 3 squared, which is 9. Negative 1 squared is 1. 0 squared is 0. And negative 2 squared is 4. Over 3. So we got 9 plus 1 is 10. 10 plus 4, 14. So I'll have the square root of 14 thirds. So this is where it's nice to use a calculator. I'm going to take out my phone and use it as a calculator. Don't tell anybody. All right. So I'm going to have 14 thirds and then take its square root. So this gives me a standard deviation that is about equal to 2.16. So that tells me that on average, each individual value, 6, 2, 3, and 1, is about 2.16 units away from the mean of 3. Some values are, like 6 is 3 units above, 2 is 1 unit below, so you have some that are less than 2 units away and some that happen to be more. So again, 2.16 is the average distance each value is away from the mean. So standard deviation of 2 means all numbers are hugged, pretty tight, close to the mean. Here we have 6, 14, and 10. Here again, you can think that, those numbers aren't, too far spread apart. So I've got my first observation is 6, second observation is 14, third observation is 10. And then my mean, I'm going to go 6 plus 14 is 20, 20 plus 10, 30. 30 divided by 3 is 10. So there's x bar, the mean. So finding my standard deviation, I'm going to take each individual value minus the mean and square it. So I'm going to go observation 1, 6 minus 10 squared, added to observation 2 minus the mean, 14 minus 10 squared, and then added to observation 3 minus the mean. And I'm going to divide that by n, my sample size. Here n is 3 because I have 3 numerical values, over 3 minus 1. So I've got 6 minus 10, which will be negative 4. I'll square that in a minute. 14 minus 10 is positive 4. And then 10 minus 10 is 0. 3 minus 1 is 2. So I'm going to have negative 4 squared, which is 16, Positive 4 squared, which is 16, and then 0 squared is 0, divided by 2. 16 plus 16 is 32, divided by 2. 32 divided by 2 is 16. Square root of 16. That is a nice, lovely, clean result of 4. I like it. I like it when it comes out clean like our second data set. So there it is. Once you kind of get in the hang of it, get the flow of your standard deviation formula, you're going to be great. Fly on and let me know what I can do to assist you.